Rules apply even when our trig functions are squared. Okay, same principles still apply. We still want the trig function on one side. So let's work on that part first. Okay, so let's add that tangent squared that's on the left side. Let's add that over to the right side. So right now we've got -2 is equal to, we had 2 tangent squares and then we added another one, so we have 3 tangent squared of theta. Okay, so since that's the only tangent we have, then let's move the other stuff to the other side. So let's add 3 to both sides. So we've got 1 is equal to 3 tangent squared of theta. Okay, this is just like, if you're getting thrown off with the trig function there, just look at that as x squared, okay? Just look at it as if it were x squared and you're trying to solve for x, all right? So we need to divide both sides by 3. So we get 1/3 is equal to tangent squared of theta. So you're probably starting to think, well, 1/3, we don't have 1/3 on the unit circle, but we're not finished yet. We still have to take the square root, okay? We've got to take the square root. So anytime we take a square root, we got to include the positive and the negative. Okay, so we've got plus or minus. The square root of 1 is 1. The square root of 3 is not a nice pretty whole number, so we leave it as the square root of 3. Now you can rationalize that if you want to. Probably will be helpful because I told y'all on Thursday to put this somewhere on your unit circle so you remember which one it is. It's either pi over 3 or pi over 6. Which one is it? Pi over 6. Wait, I heard both. It's pi over 6. Yes, it would be pi over 6, okay? It is pi over 6. But since it's plus or minus, we're going to end up with 1 in every single quadrant because it's the positive square root 3 over 3, that's pi over 6 and 7 pi over 6, where cosine and sine have the same signs. But negative square root 3 over 3 will happen where one's positive, one's negative. That's the other two quadrants. So 5 pi over 6 and 11 pi over 6. So this one has 4 solutions. Now, that will not always happen with our quadratic equations, but that is a possibility, okay, that we have 4 solutions instead of 2. Yes, ma'am?
Where did you get the square root of 3 over 3?
Rationalized. Multiply top and bottom by the square root of 3. Okay? Any other questions about that one before we move on? Okay. Let's look at another one. Let's look at 35. Okay. 35, kind of similar, kind of not. Okay, 35, we see the quadratic cosine, the cosine squared, but we also have just a plain cosine. So think about this as an equation that has both x and x squared in it. When it has both x and x squared, it's got to be equal to 0. Okay, anytime a quadratic has the quadratic and the linear, the x squared and the x, you got to get it equal to 0. So let's do that for this one. Let's add 3 cosine squared of theta to both sides. So we have 0 on the left side. Now, I like mine to be in standard form. I want that cosine squared to come first. So I had -1 and I added 3, so I now have 2 cosine squared theta, plus I have this square root 3 cosine of theta in there. Now, this is not a typical quadratic in that it's x squared plus x plus a constant, right? We have 2 sets of parentheses. How do we deal with one like this? What if that was 2x squared plus the square root of 3x? Factor, how do we factor? What are we factoring out? Take out a cosine of theta. Okay, they both have a cosine of theta, so we're going to factor that out. So we have 2 cosine of theta. We took one of them out of the cosine squared, and we factored out the cosine of theta. So we've just got a square root of 3. Okay. Relate it to solving a quadratic. After we get it in factored form, we set each factor equal to 0. Cosine of theta is equal to 0. 2 cosine of theta plus the square root of 3 is equal to 0. So let's see here. Where is cosine equal to 0? That is at pi over 2 and 3 pi over 2. How do I know that so quickly? Cosine's the x-coordinate. The x-coordinate is equal to 0 on the y-axis. The y-axis is pi over 2, 3 pi over 2. Okay, that's an easy one. The other one, we need to get the cosine of theta by itself, so we subtract the square root of 3, and then we divide by 2. So the question is, where's cosine equal to the negative square root 3 over 2? So first of all, I'm thinking about where are my x's negative. So that's in the second and third. And then cosine, that would be at the pi over 6 angles, right? Yeah. So 5 pi over 6 and 7 pi over 6. So here are our 4 solutions. Now, let me show you really quickly. I've encouraged you to check these on the calculator. Let me make sure that everybody knows how to type in the squared part of it correctly, okay? Make sure you're in radian mode, okay? Here's what you need to do. You need to do -3. You put parentheses, cosine of, let's try the 5 pi over 6. Okay, so closing the parentheses there closes the angle. I need to close the parentheses around the entire cosine, then I put the squared. Okay, so that's how you type in cosine squared of 5 pi over 6 into your calculator. Okay, you have to put parentheses around the cosine and the angle, and then you put the squared. Okay, and then I want to check the right side. Square root of 3, close my parentheses, cosine 5, pi over 6 minus, I've got a cosine squared, so I got to put parentheses cosine 5 pi over 6, close the parentheses on the angle, close the parentheses around the trig function, squared. I get the same thing on the left side as I do the right side. Okay? So, it takes a little bit of time, but I think it's worth checking. Okay, it is definitely worth checking your answers, excuse me, to make sure that they work out. Okay, let's do one more of these quadratics right here. And then the best thing for you to do is just to try some on your own. Okay, this is the third case of quadratics that we've got here. Okay, the first one we solved by taking square roots. The second one, we got everything on one side and we factored out a GCF. This is the third case with quadratics. We're going to move everything to one side. It's not going to be a GCF. It's going to be traditional 2 sets of parentheses factoring, okay? So just glancing at this problem, I do not want to deal with a negative quadratic term. So I'm going to elect to move everything, I'm going to use a different color, move everything to the right side. So I'm going to add the 2 sine squared of theta, and I'm going to add the 2. So I have 0 on the left side. I'm going to write it in standard form. So I have positive 2 sine squared of theta plus 3 sine of theta. And -1 plus 2 gives me +1. Okay, now here's a little trick that I like to show people because people get overwhelmed with the trig function being in there. Ignore the trig function for a second. Replace it with an m, okay? Replace it with an m, okay? This way, you can just focus on factoring the quadratic without the distraction of the trig function being in there. Everybody can factor that, right? I hope so. 2m times m is 2m squared. 1 times 1 is 1. Same signs. Outside gives us 2m. Inside gives us 1m. Together they make 3m. Okay? So when I set these equal to 0, I'm just going to put the trig function back in there. So 2 sine of theta plus 1 equals 0. Sine of theta plus 1 equals 0. Then I'm back to just simple linear equations. 2 sine of theta equals negative 1. Negative. Don't lose that negative. Mine looks like I've got an equal sign with 3 lines, so I'm going to fix that. There we go. Sine of theta equals negative 1/2. Sine is equal to 1/2 at pi over 6, but it's negative, so we're talking about third and fourth. So we're talking about 7 pi over 6 and 11 pi over 6. The other equation, sine of theta is equal to negative 1. That only occurs in one place. The y value is negative 1 at 3 pi over 2. 3 pi over 2.
So how do you know what when to do two of those different ones? Is what it's set up?
It's what shows up there. So the first one that we did only had tangent squared. So that means that we can just completely isolate the tangent. The second one had cosine squared and cosine. And no constant. So we factored out the GCF. The third one has sine squared and sine and a constant. So you know you're going to end up with 2 sets of parentheses to factor. Okay. So it's the same techniques for solving quadratics. It's just we've got trig functions in there instead of regular quadratic equations. Okay. And if this helps you, if subbing for those trig functions, putting just a plain variable in there, if you want to do that from the very beginning of the problem, if that helps you see it a little bit easier, that's fine. Just don't forget to put the trig function back in there for the variable. All right, so here's what I want you to